kapag non-target protein mediated, no binding to an active site of protein is required, okay? Para makapag-produce ang drug ng response or effect. Okay. Now, there are three possible mechanisms for a non-protein targeting drug to produce an effect. So, we have, for example, via colligative mechanism. Another is through direct chemical interaction. And finally, via counterfeit mechanism. Again ha, itong tatlong to are the possible ways how a drug mediates its effect even without binding to the active site of protein. So let's have first colligative property. Not property, mechanism. Okay, colligative mechanism yung way ng drug, okay, to produce an effect. So in colligative mechanism, based on the term itself, okay, colligative, meaning yung way ng drug to produce its mechanism of action has something to do with colligative property of substance. So in your physical pharmacy, you have learned no, examples of colligative property. Halimbawa, yung osmotic pressure. Okay, osmotic pressure. Okay, now talking about osmotic pressure, this is very much related to the process, what we call osmosis. Okay, ayan. Okay, so related siya sa process called osmosis. Okay, so I believe you're familiar with this process, osmosis. It has something to do with the movement, okay, movement of water, okay, movement of a solvent, particularly ang common solvent, diba, in the body is water. Paano yung movement ng solvent or paano yung movement ng water kapag osmosis? It is from a concentration, an area na low, yung concentration, to an area with high concentration. Diba? I'm talking about the solute, solute. Okay? Kapag osmosis, it has something to do with the movement of solvent from an area with low solute concentration, okay, to a high solute concentration, area with a high solute concentration. Parihara na siya kung ang inyuhang knowledge in osmosis is from high concentration of a solvent. Kung solvent, syempre, from high concentration of a solvent to a low concentration of a solvent. So here, I am referring to the solute. Okay. So an example of a drug that acts via this mechanism is mannitol. Okay, specifically mannitol, this is used as osmotic diuretic. Now when we say diuretic, nagpapaihi. Okay, diuresis, no? Nagpapaihi siya. Particularly, yung ginagawa niya, if this is, let's say for example, dito yung blood, halimbawa lang siya ha, hindi siya inabi. Halimbawa, you have here the blood on the right side, and then here is the urine. Okay, so may mga compartments. Okay. Now, ang ginagawa ni mannitol is nag-draw out siya ng water molecules mula sa blood, okay, papuntang urine. Okay, yeah. Okay, I repeat, nag-draw out siya ng molecules from blood going to the urine. Okay, so yan yung ginagawa ni mannitol. Okay? Kasi, meron kasing constituents in mannitol na pinapataas niya yung solute, okay, concentration in the urine. Now, I repeat, kapag osmosis, okay, saan papunta? Yung movement of the water, movement of the solvent, okay, doon papunta sa higher solute concentration. Okay? So, sige lang, we have a detailed discussion on mannitol as we go on the next unit sa cardiovascular drug. Okay? Kasi this is a diuretic. Kapag diuretic na kasi, it has something to do with those drugs that targets cardiovascular system. Okay? So at least for now, you know that mannitol, yung mechanism of action niya is via colligative mechanism. Okay? And that's very obvious. Wala namang involvement to wala siyang involvement of binding, no, to an active site of protein. It only involves osmosis, okay, a colligative property. Okay. Now let us have another way for a drug action without binding to the active site of the protein. So we have here the direct chemical interaction. Okay, so an example of a chemical interaction is neutralization. So you're familiar with this. This is simply the chemical reaction between an acid and base. Okay, mo siya, neutralization, acid plus base. Okay, forming a salt. Okay, so example of drugs na yung MOA nila is via neutralization, includes antacids. Okay, antacids. Okay, di ba? Para saan yung antacid? Obviously, for the management of hyperacidity. For hyperacidity. So kapag mataas yung acid sa stomach, we have antacids. They will act as a base. Okay, they will counteract, they will neutralize the stomach acidity. Okay, another example, we have sodium bicarbonate. Okay, sodium bicarbonate, this is mainly used in the management of metabolic acidosis. Okay, for the management of metabolic acidosis. Okay, ano ba yung underlying cause? Why this problem arises? Okay, this is because merong metabolic acidosis kasi yung nangyayari, sobrang mababa yung ion na bicarbonate. Mababa yung bicarbonate ion. And bicarbonate ion is a basic ion. Okay? So kung mababa yung basic ion, physiologically speaking, mababa siya sa katawan, what will dominate? Siyempre yung acidotic environment. Okay? So yan yung metabolic acidosis. So to manage this condition, we simply supply what is lacking. Kung mababang bicarbonate, bigyan yan ng basic ion. So example, sodium bicarbonate would be the source of bicarbonate ion. Okay? So that's another example. Neutralization din yan. Sodium bicarbonate would act as the base there. And another example is protamine. Protamine, this is commonly used as antidote. Antidote siya for heparin. Antidote for heparin toxicity. Okay, antidote siya for heparin toxicity. So, kung chemical reaction niya siya, okay, the protamine will act as a base. Okay? Based on the term itself, diba? Kung imuhang lantaon ang pangalan ni protamine, diba? Protamine, we can expect that by chemistry, by structure, meron siyang amine, and amine in chemistry, they act as a base. Diba? They act as a base, they are basic in property. So si protamine yung base, therefore, yung heparin, okay, will be the acid. Okay, so base, acid, neutralization yan. Okay, neutralization. Okay, again, these are agents that are considered non-protein targeting drugs. Particularly, yung way nila, yung mechanism nila is, yung mechanism nila to produce response is by neutralization. Okay, which is an example of chemical reaction. Okay. Now another way, okay, of drug to produce its effect via chemimal reaction, direct chemical interaction, is through chelation. Okay, chelation. Ibig sabihin ng chelation, we are forming. That's why it is also referred to as complexation. Okay, complexation. So one example here that has the mechanism of complexation is deferoxamine. Deferoxamine is commonly used substance, no, to uh, to counteract iron poisoning. This is very important uh, for the management, okay, of iron poisoning. Okay, so you have here deferoxamine, and let's say you have iron poisoning. Pag iron poisoning, sobrang taas ng iron level sa blood. Okay? Now, deferoxamine, yung gagawin niya, it will lower the iron level in the blood. Nagpo-form siya ng complex structure with the iron metal. Okay? Resulting to a, a compound, ferrioxamine. Okay? Now, this ferrioxamine is now an excretable form of iron. Hindi na to toxic form ng iron. So, yan yung ginagawa ni deferoxamine. Nag-form siya ng complex with iron para makapagbuo siya ng iron which is non-toxic, non-absorbable in the body, but excretable na siya. Excretable lang. Okay? So, para dali lang niyo siya madumduman na si deferoxamine para din siya sa iron. Okay? Kabisaduhin niyo lang yung pangalan ng gamot, yung first two syllable, defe. Defe. Diba? For any root word which is added with a prefix na de means removal. Ayan yung ibig sabihin ng prefix na de. You're removing something, removal. Okay? Therefore, yung kasunod na syllable. Okay? Gafe. So, kung yung siya yung mnemonics, gafe, that is the symbol of iron. So, you're removing iron. Okay? You're lowering iron. So, para dali lang mo siya madumduman ba, na deferoxamine counteracts iron metal. Okay? Forming excretable form of iron, which is the ferroxamine. So as you can see, once again, there is no involvement of protein here. Diba? This is simply chemical reaction. Okay? Direct chemical interaction. Alright? So we're done with the second mechanism. Okay? Let's have the third mechanism under non-protein target mediated pa rin. Okay? So we have here the counterfeit mechanism. Okay? Now for counterfeit mechanism, this is also known as incorporation. Okay? Again, this is also known as incorporation. Okay? Now, from the word counterfeit, di ba, ang counterfeit na term, this is synonymous to the word false. Counterfeit, false, fake. Diba? False, fake. So, yung nangyayari sa mechanism na to, kumbaga, you have a false substance that will be incorporated to the body, causing an alteration on the normal functioning ng body system. Okay? So, halimbawa ng mga group of drugs or classification ng drugs that has this mechanism are the anti-metabolites. Okay? Anti-metabolites. Anti-metabolites in general, these are also classified as anti-cancer. Okay? Anti-cancer agents din sila. I repeat, these are cytotoxic anti-cancer agent din sila. Okay? So in general, the anti-metabolites, sabi nga, they act as false agent. They act as false metabolite in our body. Hindi sila yung totoo, hindi sila yung natural na metabolites na kailangan for cell synthesis. Okay? Yan yung anti-metabolites na mga drugs. Now, para maintindihan yung MOA ng anti-metabolites, balikan muna natin yung pathology ng cancer cells. Okay? Which na-introduce ko naman somehow, diba? Briefly, last meeting. So when we talk about cancer cells, okay, siyempre, isa siyang cell, okay? A cell that rapidly proliferates, it loves to divide, okay? And since it is a cell, we have to consider what is the important component of cell. Diba? Ang important component of cell is the DNA. Kahit normal cell, no? Basta cell, unsa pa na klase na cell, kailangan yung DNA. Importante yan. Okay? Importante yung DNA synthesis. Okay? Okay? Ayan. Now, talking about DNA, okay, in your biochemistry, okay, what are those natural, not natural, and natural, nitrogenous, okay? What are those nitrogenous bases needed for nucleotide synthesis, needed for DNA synthesis? Because we have what we call the pyrimidine bases. So, nani siya mga specific example under pyrimidine, na po tayo mga purine bases. Ito yung mga natural. Okay? Ito yung mga natural metabolites, okay, na kailangan, okay, for the DNA synthesis to proceed. Okay? Ito yung dapat mag-incorporate ba sa DNA strand. Okay? And yan yung natural sa body natin ng mga metabolites for DNA synthesis to proceed. Now, dito ngayon, papasok yung gamot na anti-metabolites. Okay? If these natural metabolites in our body, okay, di ba sabi ko, kung kani sila ang ma-incorporate sa DNA strand, kani, if sila yung ma-incorporate sa DNA strand, that will contribute to the natural na DNA synthesis for the cancer cell, and that is a problem. Okay? Musamot kadaghan ang cancer cell, musamot. Okay? So karon natin mga anti-cancer agents na ang ilang mechanism is via incorporation. So magpa-as if sila, na sila ang natural metabolites. These are the anti-metabolites. Halimbawa, we have purine analogs. Kapareha niya yung structure ng mga natural purine ng body natin. We also have pyrimidine analogs. Almost the same structure with the natural pyrimidine in our body. Halimbawa ng purine analogs, we have 6-mercaptopurine. Okay, mercaptopurine. For pyrimidine analogs, we have 5-fluorouracil. Okay, 5-fluorouracil. Okay, I repeat, itong mga anti-metabolites na to, yung chemical compound nila has that molecular structure na closely similar to the natural one. That is why ma-tempt good ang cancer cell na abi niya o katong natural na, pero kapag yung kinuha niya na pyrimidine, purine is yung mga peke, that will help, no? That will stop now the synthesis, the division ng cancer cell. Kaya anti-cancer yung mga anti-metabolites. Kasi again, this purine analogs, like 6-mercaptopurine, pyrimidine analogs 5-fluorouracil, upon incorporation nila sa DNA strand, okay, ma-inhibit ang synthesis ng DNA. So, dili magpadayon, no? Ma-inhibit, dili magpadayon ang proliferation ng cancer cells. So, anti-cancer yung anti-metabolites. So, again, sila yung peke sila, dili sila katong natural metabolites. Inhibition of DNA synthesis yung ginagawa nila. Okay? So, as you can see, again, yung action nila has no involvement of proteins action, diba? Proteins active site. Okay? More on counterfeit mechanism, non-protein targeting din. Alright? So, that ends our discussion on the mechanism of drugs action. Okay? And those are examples of drugs that target a protein, and those drugs that target that do not target a protein. Okay? Ayan. So, non-protein targeting and the protein targeting. So, done na to. So, we're done here. So, let us now proceed to the last part of our discussion. We will talk about drug-receptor interaction. Okay? So, for drug-receptor interaction, we will be discussing the features of the ligands, ibig sabihin yung characteristics ng ligands, the classification of the ligands, including those theories in relation to drug-receptor interaction. Again. So let's start with the features. Ano ba yung mga characteristics or features ng particular ligand during or upon interacting to a receptor? Well, we have affinity. Another is intrinsic activity. You're all familiar with this already, ha? Affinity, when you say affinity, this is the ability of the ligand to bind to the receptor. Of course, any ligand, by the way, pag sinabing ligand, in general, in pharmacology, we're referring to the drugs. Okay? We're referring here to the drugs, exogenous source. Okay? Exogenous na ligand. Okay? But there are also few examples ng ligand that are endogenous, coming from endogenous sources, but in general, kapag sa pharmacology references, when you encounter this term ligand, we are referring to drugs. Okay? So any ligand, they have the ability, of course, to bind to a receptor. Okay? And take note, most of the drugs, okay, they are receptor targeting. Yan yung tandaan nyo. Most of the drugs that we'll be encountering here in pharmacology, most of them are receptor targeting. That is why I really encourage you to access the detailed discussion on receptor and its types. Okay? The second feature of a ligand is that they have that intrinsic activity. This is the ability of the ligand to activate the receptor. Activate, meaning it has the ability to stimulate, okay, a receptor, and eventually leading to a cellular response. Now, since not all ligands are able to activate receptor, this resulted to general classification of ligands. Diba? Hindi naman lahat ng ligands able to activate, stimulate receptor. May iba dyan, nag-block, nag-antagonize. Diba? That is why we have two general classification of ligands. First, we have the agonists. Okay? Agonists, they are synonymous to the term activators or stimulators. Okay? So, ito ha. Parehas rin na siya, equivalent na siya sa stimulators or activators. Ayan. So kapag agonist, it has both. It has both affinity and intrinsic activity. It is able to bind to the receptor, and upon binding, it is able to activate, okay, that receptor. And there are three types. Okay? Three types of agonist. We have full agonist, partial, review na lang to. Partial, then inverse agonist. So for kapag full agonist, of course, it has a full capacity to produce the maximal effect. Now, if you talk about intrinsic activity, okay, dun lang sila nag-differ. Okay? Same yung degree ng affinity nila, same, equal, yung affinity ng tatlo, they are all able to bind to the receptor, but dito sila nagkakalo sa intrinsic activity. Okay? So, let's say for instance, kapag full agonist, by theory, intrinsic activity, we have this quantal unit of value para i-measure ang maximal intrinsic activity. And let's say for instance, the maximum intrinsic activity is, example lang ha, intrinsic activity na quantal unit is between 0 to 1. So 1 would be the maximal, okay, effect, okay, for intrinsic activity. So kapag full agonist, intrinsic activity niya is 1 full, okay, full, it has a maximal effect, meaning full pharmacological response will be produced upon occupancy of that ligand to a receptor. Okay, so kapag partial agonist naman, Yung intrinsic activity niya would be less than 1, okay, but greater than 0. Okay? Again, it's either greater, in between this range lang ang iyahang activity to stimulate receptor. Okay? It's between 0 to 1, greater than 0 but less than 1. Mas masabtan ninyo ang intrinsic activity na interpretation if you apply your knowledge on dose response relationship. If you try to plot these definitions ng tatlo sa dose response graph, and I know you have that in your Pharmacology 1. Okay? So for partial agonist, this is considered to have a mixed agonist and antagonist effect. And you have to take note this, pinaka-important yun nga thing to take note, no? With regards to partial agonist. Okay? Never ever combine a partial agonist in the presence of a full agonist. I repeat, never combine with a partial agonist in the presence of agonist. Why? Because the partial agonist will dominate and it will act as an antagonist. Okay, so halimbawa, you have morphine. Morphine is considered a full agonist, a full activator of the receptor mu opioid receptor. That is the receptor. Yan yung pangalan na ng receptor kung saan nagbabind yung morphine. Mu opioid receptor. It is a full agonist siya. Okay, so expected na kapag nakapag-bind yung morphine sa mu opioid receptor, it is expected to produce all the pharmacological response, no, like analgesia. Morphine is actually the standard analgesic. No? Isa tong narcotic and ito yung standard comparison for analgesic agents. Okay? So ang pinaka-expected na result for morphine is analgesic effect or analgesia. Okay? However, in the presence of a partial agonist, if kinumbine mo with a partial agonist, halimbawa nalbuphine, it is a partial mu opioid receptor agonist. What will happen here is that yung nalbuphine will compete. Okay, it will overpower morphine, okay, in the mu receptor, causing decrease yung analgesic effect. Okay, that is why hindi pinagbabawal talaga na i-mix yung partial agonist in the presence of full agonist. Okay? So, kaya mag-dominate ang antagonistic activity, okay, of that partial agonist. Now, for inverse agonist naman, inverse agonist, talking about its quantal unit of intrinsic activity, less than 0 naman. Okay? Less than 0. So, kumbaga negative yung intrinsic activity niya. I repeat, negative yung intrinsic activity niya. So, meron siyang ability pa rin to bind kasi agonist pa rin siya, di ba? Meron siyang affinity. Meron siyang ability to bind. Okay? The same with a full agonist. But, yung PICOL response niya, yung pharmacological response niya is opposite to that of the agonist. Okay? Bali, meron na siyang ability ba to prevent the constitutive receptor activity kung absent yung agonist. Okay? Yung full agonist. Okay? So, inverse agonist. You can review your notes on dose response relationship if you graph, no? If you plot the effectivity, the intrinsic activity of this 3 types of agonists, you will easily understand them. Okay? Kaysa more on words mo magpuan. Kung i-plot lang ninyo siya sa graph, dali ka kayo ninyo ma-understand yung pagkakaiba ng tatlo based on the response. Okay? So it is already your job no, to review that. That's part of Pharmacology 1. Okay. So let's have the second classification of ligand. So we have the antagonist naman. So So kapag antagonist, meron siyang affinity. But this time, zero yung intrinsic activity. Again, zero. It's not negative, okay, but zero. Okay, no more intrinsic activity. No more ability to stimulate, to activate, no receptor activity. Okay. Now, the antagonism property of this ligands, okay, they may occur in three ways. Okay? So, meron tayong tatlong type of antagonism. Antagonism may either be based on mechanism of action, ayan, or yung type of yung type of antagonism could be based on the type of interaction, and lastly, it could be based on the type of based on surmountability of interaction. Ayan. So let's have first the antagonism that ayan. Okay, so pwedeng yung antagonism under MOA is via functional one, pwedeng receptor, pwedeng chemical antagonism. So again, let's have first functional antagonism. Okay. Functional antagonism, this is also known as physiological antagonism. Okay, I repeat, physiological antagonism, that is also considered functional antagonism, meaning nagkakaroon lang dito ng reversal of effect of a drug because of the presence of another agent, okay, which causes a response on some other tissues. Okay? Then opposing ang ilang action. Sige, halimbawa, okay, para mas masabtan. Let's say, for example, you have a ligand, a drug, you have a drug A, and you have a drug B. Okay? Then, this will be the receptor, for instance. Okay? Yung drug A, so meron siyang activity towards a receptor. Let's say a receptor is X. Then, yung drug B, meron din siyang ability to bind, but a different receptor. Okay? Bind siya, na siya activity towards another tissue. Now, upon action of these two on the different receptors, the oppose ang ilang action towards one another. Okay? Yung function or effect ng isang substance, gina-oppose niya ang activity ng other substance. Okay, take note ha again, this type of antagonism, okay, yung dalawang substance, they bind on different receptors. Kumbaga, physiological yung response ng antagonism nila. Okay? So I'll give a specific example of a drug. Halimbawa, yung drug A is epinephrine. Kanina, na-mention na din sa inyong ANS drug, di ba? Epinephrine, this is a substance, di ba, that binds to adrenergic receptor. Okay, epinephrine, it binds to adrenergic receptor. What are examples of adrenergic receptor? Do you have any idea? Ano yung mga example ng adrenergic receptor? Is it muscarinic? Is it cholinergic? Yes, very good. We have beta, alpha. Okay, very good. So for epinephrine, mind you class, now epinephrine, it has the ability on the following receptor, pwedeng beta 2. Meron din siyang ability equivalently to beta 1 receptor and also to alpha 1 receptor. Yan yung mga receptor kung saan merong action si epinephrine in the body. Okay? Now, let's extract one receptor kung asa siya gabind. Let's say, for example, sa beta 2. Asa makita ang beta 2 receptor? Sige nga. Saan usually nakikita yung beta 2 receptor? It is in the very good, it's in the lungs. Okay? It's in the not really lungs, kay dako raman kay na organ ng lungs. It's in the bronchiole. Okay? It's in the bronchiole smooth muscles, bronchioles. Okay? I repeat, beta 2, they are found on the bronchioles. Now, upon stimulation of beta 2 in the bronchioles, what is the activity? What would be the response? There would be bronchodilation, knowing that epinephrine is a beta 2 agonist. Take note ha, epinephrine is a beta 2 agonist. Okay? So yung activity ni epinephrine, kapag nakapag-bind siya sa beta 2, there is bronchodilation. Now, let's have another drug. So, okay na tayo dyan ha. Okay, another drug, we have histamine, for instance. We have histamine. Okay, so this is another endogenous compound. Histamine, it can act to either histamine 1 receptor or histamine 2 receptor. Let's say, for example, I will extract only one receptor sa histamine 1. Okay, now histamine 1 receptors, they are found in the extravascular smooth muscle. Diba, meron din histamine 1 receptor sa bronchiole smooth muscle. Okay. Now, so upon stimulation of histamine 1 in the bronchioles, this time it will cause the response of bronchoconstriction. Okay, yan yung normally activity ng histamine kapag nag-bind siya sa histamine 1 receptor. Kasi nga histamine, syempre, it will activate histamine 1, diba? So, H1 agonist siya, agonist. Ayan. So, while looking at this presentation, no, as you observe, the response of both substances are antagonistic to each other. Epinephrine, upon binding to beta 2, it causes bronchodilation. A histamine, which binds to a different receptor, which is histamine 1 receptor, the effect is bronchoconstriction. Okay? They bind on different receptors. They have different physiological effects. Physiological yung antagonism nila. Okay? So that belongs to functional antagonism. Basta as long as you know that this drug, another drug, will bind to a different receptor, then antagonizing yung effect nila, that is considered functional antagonism. Okay, physiological antagonism. Okay, next, let's have the receptor antagonism. This is also called as pharmacologic antagonism. Okay, pharmacologic antagonism. So this time, yung dalawang substance, okay, meron ka ulit dalawang substance, let's say like you have a drug A, then you have a drug B, and okay. Ngayon, naturally, the other one will serve as receptor activator, while the other will try to compete, no, with the same receptor, okay, with the same receptor, producing an opposing response. So this time, you have two drugs, okay? Ang isa activator, ang isa inhibitor, okay? Inhibitor, okay? Now, both of these bind to the same receptor. So let's say this is the ligand AB, then the receptor X, okay? Parehas na sila ginabind. Ang isa mo activate sa receptor X, ang isa mo inhibit sa receptor X. So pag ingana gani ang antagonism, okay, they bind on the same receptor antagonism yan. Okay, pharmacologic antagonism. Okay, so halimbawa, epinephrine ulit. Okay, epinephrine. So epinephrine, okay, let's extract another na pod nga receptor kung asa siya gabind. Let's say beta 1, okay, receptor. Yung X is the beta 1 receptor. Okay? So epinephrine as as agonist of beta 1, we all know that beta 1, this is um, very pronounced sa heart, di ba? Nani siya sa heart makita. Okay, ang beta 1 receptor. So, the effect kapag na-stimulate yung beta 1 receptor in the heart, okay, that will cause, okay, the response increase inotropy. Tama? Inotropy. That is for epinephrine. Upon activating beta 1 receptor, okay, increase yung inotropy. Kumbaga, kung increase ang inotropy, increase yung force of attraction. Tachycardia, kumbaga, yung response, okay? Tachycardia, okay? Now, we have other drugs that could block actually the same receptor, okay? A beta 1 receptor. Example, those beta blockers, di ba? Natin mga ginatawag na beta blockers, okay? So, beta blockers, those ending in olol, di ba? Blockers, okay? Beta blockers, so gina-inhibit nila, gina-block nila ang beta receptor. Let's say, for instance, those non-selective ng mga beta blockers, they can block beta 1, beta 2. So, ayan. So, meron siyang affinity to beta 1 receptor. So, pag block niya sa beta 1, okay, that blocks the inotropic activity of the heart. So, in opposite, okay, na ay opposite ng inotropy, there would be bradycardia. No? Bradycardia naman. Okay? Okay? Bradycardia yan. Okay? So that would be the example of receptor antagonism. Okay? You have one drug, okay, that acts as activator on the same receptor, then the other drug would inhibit or will block that same receptor. So, antagonism, receptor antagonism. Next, for chemical antagonism, the examples under this na mention na natin kanina. No? So, for chemical antagonism, this is also known as inactivation process. Kumbaga, nagkakaroon lang ng direct chemical interaction. So, yung mga kanina nga example under direct chemical interaction, you can have those here. No? Example, yung protamine. Di ba? Protamine plus heparin, ano yung chemical reaction? Ano yung chemical reaction under this, di ba? Neutralization. You have a base, amine, a base, protamine, that will counteract the heparin toxicity. So, neutralization. Okay, so chemical reaction. So, as you can see, antagonism yung activity nila. Okay, the antagonist, opposing yung activity nila. Next, we have the furoxamine. Okay, in counteracting the iron poisoning. Okay, so yung chemical reaction naman dito involved would be chelation. Okay, so again, sa chemical antagonism, gina-inactivate ng isang substance yung isa, okay, to manage toxicity, to manage poison. So, in activation process, that's chemical antagonism. Okay, so overall, those are the types of antagonism based on MOA. Okay, we're done with based on mechanism of action. Let's proceed. Okay, let's proceed to type of antagonism. Okay, na based naman on the type of interaction. Okay, so dalawa lang to. Kapag yung type of interaction is reversible interaction, meron din tayong irreversible interaction. So kapag reversible interaction, temporary. Okay, temporary kumbaga yung bonding na nabuo between an antagonist towards a receptor. Okay, so you have here antagonist upon binding of that antagonist towards the receptor, yung nabuong bond, okay, ng antagonist to that of the receptor, sobrang weak. Okay? Sobrang weak, very weak, no? Weak yung force of attraction. Okay? Halimbawa ng mga weak force of attraction in pharmacology that includes the non-covalent bonding. Okay? Mga non-covalent bonds. Okay? Those are examples of weak force of attraction. Okay? So non-covalent bonds that includes van der Waals, hydrogen bonding, ayan. Okay? Dahil weak ng force of attraction, reversible, pwede pa ma-reverse um, ang interaction. Okay? So, temporary. Whereas, kapag irreversible yung interaction, merong permanent effect dito. So, greater than 24 hours, that would be the, kumbaga, it will last hours kapag irreversible type of reaction. Bakit may permanent effect? Bakit may permanent effect as long as ang antagonist is bounded to the receptor? Kasi this time, hindi na weak yung force of attraction yung nabuo upon binding ng antagonist towards the receptor. Okay? So, parang, gano'n na. Okay? Ayan. Okay? So, upon binding antagonist to that of the receptor, okay, it produces a strong bond. Okay? Halimbawa, covalent bond. Okay? Covalent type of bond. That is considered the strongest bond in chemical structure ng mga drugs in pharmacology. Okay? Dili siya pareha sa chemistry. Opposite nga naman sa chemistry. Kasi sa chemistry, hydrogen bonding is the strongest bond. Okay? Pero sa pharmacology, it's the covalent bond that is considered the strongest bond. So again ha, kapag ang antagonist covalently bonded to a receptor, okay, that will cause a permanent effect. Really give us a permanent forever naka-intake ka ng substance and permanent effect. No, as long as ang kanang drug is being binded to that receptor, okay, it would produce a permanent antagonism, a permanent interaction, irreversible yung interaction. Which I can explain a little bit later on drugs. Okay. Next, so done with those antagonism based on the type of interaction. Lastly, we have those type of antagonism naman based on surmountability of interaction. Okay, so dalawa lang po. Ang isa surmountable, yung isa non-surmountable. Okay, so surmountable, ibig sabihin competitive yung antagonism. Surmountable, kaya natin ma-surmount, no, yung effect ng antagonist. Pwedeng ma-overcome pa. Okay, so by definition as stated, we can completely overcome the effect of antagonist by simply increasing the dose of the agonist. Okay, so halimbawa, you have here, this is the receptor. Siyempre, a receptor will have that active site. Diba? So, halimbawa, yung antagonist, okay, is there, present. Now, competitive ang antagonism or surmountable yung type of antagonism dito kapag we can overcome the antagonism effect via increasing the dose of our agonist. Okay? So that is competitive. Okay? Again, competitive antagonism, ibig sabihin, kaya natin ma-surmount yung effect ng antagonist by increasing the agonist, the dose of the agonist. Okay? Whereas, kapag naman non-competitive antagonism, non-surmountable na this time. Non-competitive. Okay? Non-surmountable na yung effect ng antagonist. Even pila pa ka-dose ng agonist ang inuhang i-counteract with that of antagonist. Okay? Bakit non-competitive, non-surmountable na this time? It is because of the type of antagonism. Okay? This time kasi, hindi na ordinary antagonist, okay, ang present kapag yung interaction is non-surmountable. This time, let's say for example, this is the receptor. Ayan. Okay. So this is the receptor. Ito yung active site. Okay? Active site of the receptor. Active site of the receptor. Okay? This time, yung antagonist dili siya mo bind dito sa active site. Okay? We have now here the allosteric antagonist. This is now an allosteric antagonist that is being involved to a non-surmountable type of antagonism. Again, kapag allosteric antagonist na gani, ang involved sa antagonism that is already non-surmountable. Kasi yung antagonist will not bind to the active site, instead it will bind to the allosteric site. Okay? Mabind siya sa allosteric site ng receptor. Ang mahitabo, kung mabind gani siya sa allosteric site, it will cause change in the conformation of the receptor's active site. So, dili na kana ang forma sa active site ng receptor. Let's say, for instance, ma-change na siya into this way, or nag-bind na ang antagonist dire. Ito yung antagonist. Saan nag-bind yung allosteric antagonist sa allosteric site ng receptor. What will happen to the active site? It will change its conformation. Kaya, yung agonist, okay, na supposedly, okay, fitted unta yung shape niya to the original active site ng receptor, dili na siya mo swap sa bago nga shape ng active site kapag pagka-conform, okay, kapag binding ni allosteric antagonist. So, biskan pag imong i-increase ang agonist diri, it will not surmount the effect of antagonist. Okay? I repeat, increasing agonist here, dose of the agonist, it does not overcome the antagonism. Okay? So that's non-competitive, non-surmountable. Okay? So those are the different types of antagonism based on MOA, based on the type of interaction, and based on surmountability of interaction. Okay, and the last slide, okay, you can just read this one. Okay, for the theories, for the theories, hypothesis on pharmacologic response of receptors when occupied to a ligand. Okay, so we have three. We have hypothesis of Clark. According to Clark, he states that yung maximum daw, yung full na Picol effect, okay, it is being obtained if all the receptors are being occupied, which somehow makes sense, no? However, for the hypothesis of Peyton, which is also known as a weight theory, sa kanya naman, it's something to do with the stimulus. No? Yung maximum Picol effect daw po ng isang drug, it does not depend on the occupancy of the receptor by a ligand, but based on the stimulus. And the most popular na theories when it comes to the maximum Picol effect ng drug towards occupancy sa receptor is yung kay Arians and Stephenson. Okay? Yung hypothesis of Arians and Stephenson, this is also known as occupancy theory. According to them, the maximum pharmacologic effect daw po lasts as long as receptors are occupied. Okay?